Alright, today we are going to continue our talk of functions, this time specifically about domain and range. Mentioned these briefly last time. The domain is your set of input values, your x values. We call this the independent variable. And your domain values is everything that you can put in to a function. Your range then is your set of output values, your y values. They are dependent upon whatever you put in, so they are your dependent variable. And it is everything that you can get back out from your function. To write our notation for domain and range, we're going to go back to using interval notation. You could also use inequalities. We're going to focus on the interval notation to practice that. So things like all real numbers being negative infinity to infinity, or maybe it's you can go from negative 4 to 16. A reminder that the bracket means it's inclusive, the parenthesis means you get really close to 16, but you never actually touch it. That's a skill from a previous unit. So we're going to start by focusing on domain, which again is your input values, your x values, all of your independent variables. We're going to look at them graphically first. So graphically you can read from left to right because we're talking about x values, which represents the x-axis. Reading from left to right will be reading from lowest to highest. So if you think about really big negative numbers, if you put in a big negative number, you're going to get a value back out. If you put in any of these values for x, you will get a y value that corresponds. Might be above the axis, below the axis, but you're always going to get something back out. In this case, for a parabola, our domain is going to be all real numbers. I can pick any number that I want to, and I will be able to square it, subtract 3, and get a number back out, which is depicted right here in this graph. So this would be the way to write all real numbers. You can also use the all real numbers symbol. Next we have this cubic function. Similar thing, we're going to assume this is a cubic going forever in both directions. If I pick any x value, reading from left to right, big negative numbers, those are going to get me values back. These numbers around 0 are going to get me numbers back. Numbers out here will get me positive numbers. So again, our domain is going to be all real numbers, negative infinity to infinity. This is where it gets a little bit more interesting. If you read from left to right, if I were to pick a big negative number and plug it into my function, I don't get any points back on my graph. It's not until I get to this x value right here, which is -1, that I actually get something back on my graph. After that, if I plug in any number bigger than -1, I will get points corresponding on my coordinate plane. So that means that my domain has to be all of my x values that are greater than or equal to -1, because when I put in -1, I do get back that red dot right there. So writing that in interval notation would be everything from -1 to infinity, and I will get values back out. So that's by looking at the picture. You're going to read from left to right. Algebraically, it often helps to think about what x values don't work. And then your domain is all of those things that do work. So, for instance, for this first one, which was our x squared minus 3, is there any number that you cannot square, multiply it by itself, and then subtract 3? Well, you can square negatives, get an answer, square positives, get an answer, square 0, fractions, decimals, all of that. So that's why our domain ends up being all real numbers. Likewise, right here, is there any number that you cannot cube? So multiply by itself 3 times over. If you take a negative times a negative times a negative, you get a number, you're good. 0 times 0 times 0, positive times positive times positive, etc. So again, we're going to get all reals. This is where it starts to get interesting. Our overall function, this one was squaring, this one was squaring, this one was cubing. Here we're taking a square root. So what kind of numbers can you not take a square root of? Well, you can't take a square root of negative numbers and get back a real answer. So that means that whatever is in this square root, whatever number that is, has to be positive or 0. Because if it was negative, we would not be able to take the square root and get a real answer. So if this needs to be true, that means x itself needs to be greater than or equal to -1, which we would write -1 to infinity, matching our graph up here. And then this last one, if we think about 2 over x minus 5 as our function, we have to think about, can you put in negative numbers? Could you divide by a negative? Sure. Can you divide by a positive? Yep. Can you divide by fractions? Sure. Can you divide by 0? And the answer is no. this dividing function, we cannot divide by 0 in the reciprocal function, so that means that x minus 5 cannot be 0. Well, that means that x itself cannot be 5 if you add that 5 to the other side. So we can write that in our interval notation as we want everything to 5. We're going to skip over 5 and continue on the other side of it, the rest of the real numbers. So that's domain, reading left to right and thinking about your x values that don't work, and then the ones that do work create your domain. Range, your output, your y value, your f of x, your dependent variable, can be approached in a similar way, first graphically, but this time instead of reading left to right, we're going to read from bottom to top because we're talking about all of our y values. So looking from the bottom up, are any of these y values outputs on our graph? Well, there's no part of our graph that exists down here until you get to this value right here. This is the first y value that you're going to touch, which according to the graph is -3. You get -3, you get -2, you get 1, all of these numbers that are above -3. So that means our y values are greater than or equal to -3, which we would write as -3 to infinity. This one, looking from bottom to top, our lowest value, what exists going on way down here, what's the first y value? Well, this is going forever in the negative direction, which means that our lowest y value is going to be -infinity. And this is extending forever. What's the highest value you're going to reach on your graph? Well, it's going to keep going to infinity. So in this case, our range is all reals. This is again the one where it starts to get a little bit more interesting. If we look from bottom to top, what's the first y value that we come across? It's going to be this one right here, which is a y value of 1. So we need all of our y's to be greater than or equal to 1, because then all of these will continue to grow in our square root function. So we're going to write everything 1 and above. Then this last one is a picture of the 2 divided by x minus 5 that we looked at earlier. If you notice at 5 there is an asymptote, because we said that is a domain value that does not work, right? An input that's not going to give us an answer. But here we're looking at range, so we're looking from bottom to top. What's the lowest value going on down here? Well, that's going to be our -infinity. But as you move up, we then all of a sudden have to skip over this value. There's something going on here. We're going to skip over 0, and then we're going to pick up right on the other side of it and continue all the way up to infinity. So again, reading from bottom to top, we go -infinity until we get to 0. Have to skip over 0 because it looks like there's an asymptote there, and then continue on to infinity. Alright, so 3 questions here. First, is this a function? If you recall from our last video, does it pass the vertical line test? Blue and orange are only ever intersecting once, so we're going to say yes, this is definitely a function. What is the domain? So domain, we said we're going to look from left to right. So the first value you can plug in, this stops right here. Okay, there's nothing past this on the graph because there's no arrows extending. The first x value you can put in is going to be -5. And the last x value you can put in and still get a point back is going to be +5. Talking about your range, bottom to top. What's the lowest value that you first encounter? Well, that's this one right here, which is -3. And then what's the highest value that we get to? That's going to be right here. That's going to be +3. So domain, left to right, range, bottom to top. Similar questions happening here. Is this a function? Well, it's kind of a weird looking thing, but red and orange are only ever intersecting. Right there's a little questionable, but we're good because there's only a dot here, and that's an open circle. Till here, we're okay. So yes, this is going to be a function. Let's talk domain. So big negative numbers I can put in. This is going forever. That's because it has the arrow there. So big negatives all the way until I get to -1. then I have to skip this region right here. This part of the domain, there's no y values that correspond. Pick up again at 1, continue, I can put in 3, get an answer. 4, 5, 6, good, but anything past 6, there's no graph because there's no arrow extending. So we're going to say our domain is negative infinity until negative 1, but I can't actually plug in negative 1 because I don't get a value back. Then I'm going to pick up again at 1 with the filled in circle, and there should be something going on at 3, but actually I can just say I can go all the way until 6, because at 3 I do actually have a value. Looking at the range, again, bottom to top, what's the lowest value that you encounter? Lowest value is going to be negative infinity. And we're going to keep going, keep going, keep going. I'm still getting values out all the way until 6, but I don't actually get 6 back as a value, so I'm going to say 6, but not inclusive. State the domain and range for each function. So thinking about your graph and thinking algebraically, for your domain, this is going to be a linear function. Is there anything you can't add 4 to? I think we can add 4 to any real number. So our domain is going to be all reals. When you add 4 to any real number, the range that you get back out is also going to be all reals. Is there any number that you cannot cube, multiply by itself 3 times, and then add 2? Positives, negatives, fractions, decimals, 0, all of those work to cube and then add 2. And when we do that, we're going to get back all of our numbers, negatives, positives, 0, fractions, decimals, etc. So this case, our function is the dividing function, and we talked about on a previous slide. The dividing function has problems when the bottom is 0. So our domain has to be everything that doesn't make the bottom 0. Well, what's going to make the bottom 0 then was negative 2, so we can have any number we want except for negative 2. We got to skip it, otherwise we won't get a value back out. When we think about our range then, thinking about the graph that we had before, this one, what values are you not going to get back out? Well, this whole thing is never going to equal 0 because the top won't ever equal 0. And for right now, I'm going to ask you to trust me on that until we start talking about the reciprocal function in a unit coming up. Okay, you could also graph this to get the range. That's the way we're going to focus on range in this course. The last one then is another square root function. We talked about whatever is underneath this square root has to be greater than or equal to 0, otherwise you will not get a real answer back. So that means that x itself has to be greater than or equal to 16. So to write that, 16 to infinity, when you take a square root, what kind of numbers do you get back out? If you can only take a square root of positive or 0, you're only going to get back positive or 0. So y itself has to be greater than or equal to 0 as well. This should be inclusive. Again, for range, it does get tricky trying to think about it algebraically. So if you need to graph it on your calculator or on Desmos, you can do that. Helps you see the picture reading from bottom to top. And that concludes our domain and range.